Hello! In the previous clip, we have seen how to multiply these two polynomials, and we reduced them modulo an irreducible polynomial. Now we will use this irreducible polynomial due to the fact that we want to see how to use the XTIME algorithm, which uses this irreducible polynomial. So in order to check the two methods, we will apply the first method for this irreducible polynomial, and then we will use the XTIME algorithm in order to see how to multiply them. So we multiplied these two polynomials using the same method. So we multiplied the first polynomial by the first term in the second polynomial. The result is here. Then the first polynomial is multiplied by the second term in the second polynomial, and the result is here. And then we put this result in decreasing order, and we have here a place for a term which is not in our polynomial. So we want to see the remainder, and we will use the same method. 9 minus 8 is 1, so x powered by 1. We will multiply this irreducible polynomial by x. So we will have all these powers increased by 1. So we will have 8 plus 1 is 9, x powered by 9. 1 plus 4 is 5, so we will have here x powered by 5. 1 plus 3 is 4, x powered by 4. 1 plus 1 is 2, x powered by 2. 1 plus 0 is 1, so we will have x. So due to the fact that the coefficients are computed modulo 2, we will have 1 plus 1, which is 2, modulo 2 is 0, so we will have 0 here. Then we will have 8 powered by x powered by 8 plus x powered by 7 plus x powered by 6 plus x powered by 5 plus this is 1 plus 1 is 0 plus x powered by 3, and that's all. So we will have here x powered by 0 because we have 8 minus 8, and we want to continue our computation because we still do not have a polynomial with the maximum degree, with the degree at most 7. So we will have here x powered by 0, which is 1. So we will have 0 plus 8, so we will have this irreducible polynomial x powered by 8 plus x powered by 4 plus x powered by 3 plus x plus 1. The result will be x powered by 7 plus x powered by 6 plus x powered by 5 plus x powered by 4. 1 plus 1 is 0 plus x plus 1. So that's the remainder. So we can write here the result. So the result will be x powered by 7 plus x powered by 6 plus x powered by 5 plus x powered by 4 plus x plus 1. We may also write this polynomial as an byte, as a byte. Okay, and now let's see the algorithm, XTIME algorithm. The input will be a polynomial with the degree at most 7. So the degree is at most 7. And the coefficients are in Z2. We discussed in the previous video that we may write a polynomial as a byte. And the output of this algorithm will be the polynomial given as an input multiplied by x. So that's what this algorithm does, and reduces the result modulo this irreducible polynomial. So we will have two cases. The case when the coefficient of x powered by 7 is 0, this will be the case 1, and the case 2 when this coefficient will be 1. If we would be interested to multiply a polynomial by let's say x times 5, so we will multiply this polynomial by x by 5 times. So this, let's say this is the polynomial we want to multiply by x powered by 5. So we will multiply this polynomial by x and the result again by x and again by x and again by x and again by x. And this will be the method we will use in order to apply XTIME algorithm. So we will apply XTIME algorithm for the first multiplication, then for the second multiplication, and so on. In our case, we will multiply it by x, the first polynomial, by x powered by 2. So we will apply XTIME algorithm powered by 2. XTIME powered by 2, and we will have as an input this polynomial. Okay. Okay, so that's the algorithm. It is very simple. When the first coefficient C7 is 0, all what we have to do is to shift the positions of the coefficients with 1 to the left, and in the end we will have a 0. In the other case, we will shift again the coefficients by 1 position to the left, but we also will have to compute an XOR between the third coefficient and 1, the second coefficient and 1, and the coefficient 0, C0 and 1. That's because in our irreducible polynomial we have x powered by 4, x powered by 3, x powered by 1. So this is the corresponding XORed values. Okay, so now let's apply the algorithm. We have to write this polynomial as a byte. and it will look like this. The first coefficient is 1, which is C7, C6 is 0, C5 is 1 because x powered by 5 exists here in our polynomial. The coefficient for x powered by 4 is 0. The coefficient for x powered by 3 is 0. The coefficient for x powered by 2 is 1. For x powered by 1 is 0. And for x powered by 0 is 1. So our byte will be 1 0 1 0 1 0 1 0 1. Okay, and we will be interested now to apply XTIME on this input. So this will return us this polynomial times x. Okay, so we will have to compute XTIME powered by 2 because we have here x powered by 2 XORed with XTIME by the same polynomial, because we have the same polynomial times x, just an x. So this will be 1 0 1 0 0 1 0 1. Okay, so again we want to multiply these two polynomials. Due to the fact that the power here is 2, we will apply XTIME 2 times, just like in this example. This is 5 times, but we will apply it only 2 times. So XTIME over this polynomial once, then XTIME on the result of the first computation. Then XORed with XTIME by this polynomial, because we have this polynomial times x. Okay, so in the end we are expecting to get this polynomial x times x powered by 7 and so on. Okay, let's compute x time by this polynomial 1 0 1 0 0 1 0 1. Okay, I will check it again. 7 6 5 4 3 2 1 0. That's correct. Okay, so we want to check if this XTIME, if this input is in the case 1 or in the case 2. So in our case, the first coefficient is 1. So we are in the case 2. Okay, what do we have to do? We have to identify the coefficients C6, C5, C4 from this input. So this is C6, this is C5, this is C4. Okay, so we are in case 2. So the result will be computed as this. We will have 0 1 0, exactly like they are here, just shifted one position to the left. Then we will take C3, and we will have an XOR with 1. Then we will have C2 XORed C2, which is 1, XORed by 1. Then now we have C1. This is C1, so it is just a 0. And in the end we have C0 XORed by 1. Sorry, I have to write it with green. So this will be 1 XORed by 1, and that's, and in the end we will have a 1. Okay, so we remember the XOR function, and this will give us 0 1 0 1 0 0 0 1, and that's all. This is XTIME over this polynomial. Now we have to compute XTIME powered by 2, and this is of course our input is 1 0 1 0 0 1 0 1. That's our input, and this will be equal to XTIME by XTIME by our polynomial 1 0 1 0 0 1 0 1. Okay, now the result will be XTIME on this input, and this input is this one. Okay, so it will be 0 1 0 1 0 0 0 1. That's our new input. We are in case 1, and what we have to do is the following things. We have to shift the coefficients by 1 and put a 0 to the end, and that's all. So the coefficient C6 is this is C5, this is C4, and so on, and this is C0. So we will shift all these bits by one position to the left. 1 0 1 0 0 0 1, and in the end we will put a 0. Okay, and that's all. So what we have to do now is to replace this value here. So this will be equal to, so this is the value of this, so we will put it in here. 1 0 1 0 0 0 1 0. So this will be XORed by, so XTIME is already computed by this value, this polynomial, and the result is this. So we will have to XOR it with this 0 1 0 1 0 0 0 1. So this will be equal to we have 1 XORed by 0 is 1. 0 XORed by 1 is 1. Okay. 1 XORed by 0 is 1. Okay. 0 is the fourth bit. 0 XORed by 1 is 1. Okay, the fifth bit, 1, 2, 3, 4, 5. 0 XORed by 1, 2, 3, 4, 5 by 0 is 0. The sixth, 1, 2, 3, 4, 5, 6. 0 XORed by 0 is 0. 1 XORed by 0 is 1. 0 XORed by 1 is 1. And now we check with the result we obtained above. So we have 1 here for x7. That's correct. We have 1 for x6, 1 for x5, 1 for x4. This is for x3, for x2, for x1. That's correct. For x0, that's correct. So that's the second method. I hope this will help you. Please subscribe, press the button below, and you will be announced when new video clips will come. Okay, good luck with your study and see you in the next videos. Goodbye.